Cloud Seekho workshop. This is the third seminar conducted by our fellow core team member Ali Osaid and our ex-collaboration lead Mahanur Arshad. They are trained by Googler to guide you all through the intricacies and the complexities of Google Cloud. So without further ado, let's begin.
Assalamu alaikum everyone. वेलकम बैक फर्स्ट ऑफ ऑल एंड आज का जो हमारा टॉपिक है सबसे वो है वर्टेक्स एआई। अच्छा, वर्टेक्स एआई से पहले मैं थोड़ा सा क्विकली ब्रीफली इंट्रोडक्शन दे देता हूँ मशीन लर्निंग का। सॉरी, मशीन लर्निंग का। वैसे तो मोस्टली सबको आइडिया होगा मशीन लर्निंग का,
Can
बट
we communicate with this in English?
सॉरी,
Can you convey this meeting in English?
okay, I will try. Okay, so I would like to give a briefly quick introduction about machine learning. Basically, what happens normally, we give instruction to computer, and when we give instruction to computer, computer generates output for us, right? So, if the computer generates a false output, we does not blame the computer, right? We blame us that we does not give the right instruction to the computer. ठीक है, but in machine learning what happens is that when we computer generates a wrong output, it is based on the data we provide to the computer. The data that we give the provide to the computer, it gets trained. The computers learn from some patterns. There are many machine learning algorithms we have, which we will does not discuss in details, but we will learn shortly. Okay, so machine learning examples. There are many machine learning examples we have. We have recommendation system. If you guys have watched YouTube videos, like, and there's for example, if you watch some kind of funny video, right, and you get recommendations according to it. That's how algorithm works. There's another example like email spam filter. What happens is that, for example, if you get a spam email, it just gets filtered and goes into the spam folder, right? The options we have on Google Cloud about machine learning is like we have BigQuery, we have Auto Machine Learning, we have pre-built APIs, and some custom training. These are all the options that we have in the Google Cloud that provide us for training machine learning models and deploying. Now we have a understanding about what is machine learning, right? So now let's talk about Vertex AI. Vertex AI is basically before we go into the Vertex AI, but the problem we face when we are building machine learning models is that we have to scale that, right? We have to monitor them, and there's another thing called DevOps. Like if someone knows about DevOps, like continuous integration, right?
Automation testing or
Yeah,
automation or deployment or development.
yeah, yeah. That's all we have to have to look out. But in Vertex AI, these things are just like exclude, and we only have to focus on to solve the complex problems we have. Okay. In Vertex AI, we have two options. Auto ML. In Auto ML, we does not have to code. Like there is no coding required. Okay. If your coding skills are not good, you don't have to worry about it. And there's another thing like custom training. If you want more control to your to your machine learning model, then you go for customer training. Otherwise, AutoML is best option. Okay, now we will start the lab. Let me just share my screen. Give me 1 second. Sorry for the delay. Just 1 second. Guys, is the screen visible to you? Can you guys see the screen?
Yes.
Okay. Okay, first of all, this is the dashboard we have. This is the navigation menu, and this is the Cloud Shell. We have to activate the Cloud Shell first. Okay. Now, first of all, are you guys are following? Because have you guys seen the video like how to configure the Cloud Seekho lab?
Pardon?
Have you guys watched the video in which Manu guide you to how to configure a Cloud Seekho Google Cloud? Sorry, Cloud Shell. This like whole thing. How to access it? Are you guys are following through or just like
Yes, we are following.
okay? Okay, so in the navigation menu, we go scroll down and here you can see there is written more products. Click on it, and in the last section we have this Vertex AI. Can you guys see this? And here we have Workbench. Sorry. Okay. Before we jump into this, we need to like enable some services that we are going to use. I already have written it down. I'm going to share in this chat. Let me just copy and paste. Um, you have to write this in your Cloud Shell. This will take a few minutes. Okay, after this, there are some few other things we need to enable. I'm going to write it down in the chat one by one. We need to create a Vertex custom training account, and there's a few other things. The last command basically give access to the cloud Google Cloud storage to store the data. Then there is the last command. We need to add the I am admin ID project ID basically the project ID we have. We need to add it. Okay, now let's start. Okay, so this is the Vertex AI, and first of all, we need to create a virtual machine basically, and for that, you need to go to this user manage notebooks. Okay, after that, we need to create new workbench.
Audio is not clear. Please check it.
Sorry,
Something your voice
Audio
is
is
breaking,
not
sir.
clear.
voice is not clear.
Sometimes like cracking voices are there.
Um, okay, let
Cracking
me
voices
see.
are in your voice. Please check your
Um,
microphone.
is my voice clear now?
Yes, sir. No, it's clear.
Okay. So this is the name for our instance. And this is a zone and regions. Basically, there is a region, and they have three zones. We have A, B, C. We will select the default one, and then we have some operating system because our virtual machine is need a operating system to work with. And then we have our environment. Basically, TensorFlow is like a service that Google provides to build and deploy machine learning models. If you need more control, you guys can go to the advanced options. And here we can have like other options, for example, like environment variable, machine type. If you need larger virtual machines, you guys can select that. Most commonly, E2 is the best option. And after that, we click on create. This might take few minutes. Virtual machines basically takes time to set up. Sorry for the delay. Normally, it does not take this much time. Might be my internet is slow. Hmm. Okay, here we go. So we have set up a virtual machine, and then we have to go to the Jupyter lab. Can you guys see the screen? Or I have to switch. Wait. I have to switch to the another tab. You guys can see this. You guys can see the screen, right? Okay. This is the interface you will get after opening Jupyter Labs. Okay, so in this notebook, we have like terminal, some text files, or like other Python files. We can build and deploy our machine learning models. I can give you like a quick overview how to do that. Currently, I don't have any some data or anything, but like you can guide you all that how can we set up. Basically, we have like a dummy project right now. Let me just clone it. This will take a few seconds. Okay, just wait a second. I have to install the dependency for this project. Mm, okay. To run the file, you just basically all you have to like um, manually you can what you can do is you can go to the start button. Okay, or you can also do this run the file with your shift and enter. You guys can run the file, and you can guys can also use the terminal, and this is just like an online editor for you guys to like to build and deploy machine learning models in your virtual machines. Jupyter's help us like to deploy and build machine learning models. There's also other tools Google provides, but Jupyter is one of the best out there. Does anyone have any questions right now? Um, Up till now? Okay, I assume there is no questions. Okay, let's move on to our next lab, which is basically the Google Cloud Speech API. We are going to talk about the Google Cloud Speech API. Just wait a second. Let me switch my screen. Sorry for the delay. Okay, so can you guys see the screen? Can you guys see the screen, right? Okay, so to talk about like what is speech API basically is, you guys, most of you all watch YouTube videos, right? And sometimes the video is not in English or in your native language, so you have to open the captions, right? So behind the scene, what is happening is that um, in the Google Cloud Speech API is that it converts the user speech into your native language or in some other languages. It's all depends on you, and that's how it works. But like behind the scene, there's machine learning models that have all the data, and then it converts into um, some files and then to your native languages to enable the Google Cloud Speech API. So you can build some projects with it. You need to navigate to the menu and then credentials, and then you have to generate a API key. Basically, API key is something you need to access to your API because you does not want to give access to your API to everyone, right? If I give a example, real life example, for example, you are a user, okay, and the university is the API, okay. You need to access the API, right? But there's a middleman standing security guard basically checking your API key, your student ID card, right? If you have the student ID card, it will let you pass. But if you don't, you won't be able to pass from that point onwards. So that is why API key is very important because if you does not have API key, everyone can easily use your API key and spam it. So API key is must. We need to copy the API key and we need to activate Cloud Shell. Okay, so first we have to export the API key because export API key basically means that we can always reference to through the variable. We does not need to like paste the whole API key again and again. I'm using my API key here, but you guys have to use your own API key you will get from here. Not a very. I'm sorry. Okay. Now we have a variable called API key which will contain my API. So after that we um, have to go to the compute engine, and you guys can see there's one virtual machine is running. I need to connect to the SSH. Let me share my screen again. Wait, this is another tab. You guys can see this pop up, right? Okay, this is the SSH of our virtual machine. Um, First of all, what we need to do is that we need to touch the request JSON, which contains our file. The basically this I will show you just like a dummy what this APIs do, like dummy idea. Or like, give me 1 second. Okay, this will open the file request.json. Okay, now in this file, what we have to do is that we have to um, paste one command. I already done that. I will share that in the chat. Um, there you go. Okay. After this, you have to press Control and X, and then Y to save it. Okay. After pressing Control X and Y to save the file, the data you have insert, you need to call the API. To call the API, we basically gets like endpoint in which we can access the API key. I already have that the API access endpoint. Let me just share with you guys. Okay. To call this API, all you just have to do is that call the endpoint. Wait a second, there's some error. Um, Let me just double check. Hmm, Let me just check. Wait. Yes, my API key is not working. I have to manually insert it. Okay, here we go. So the text file was basically how old is this Brooklyn Bridge, and also that speech, the conversation, and you can guys can access the API through this endpoint right here. This is the endpoint. This will contain your API key. That's how you can enable this API, and like you guys can use this API to in your projects. This will help you build some projects. Like you can use a converter, like speech converter, or some other kinds of projects. That's all for my side. Does anyone have any questions? Mm, I guess that's it. Over to you, Manu.
Okay, Jazakallah Ali. Sahi. So, first of all, again, I'd like to welcome all of you to workshop 3 of Cloud Seekho program. Sahi. I will be starting sharing my screen actually. Where now? Screen. के बारे में सीखेंगे और फिर उसके बाद we'll be conducting 2 labs. ठीक है? is done. Ali, can you stop sharing your screen, please?
Yeah, wait a second. Sorry.
Right. It's okay. It's okay. Hmm. Please wait a minute, everyone. Oh, thank God. All right. This should be up in a minute. Sahi. Is it available to everyone?
Yes.
तो सबसे पहले we are thanks. Okay, so सबसे पहले we're gonna go to our slides. Okay, तो Google VPNs जो होते
Ma'am,
हैं हमारे जो virtual private networks होते हैं.
ma'am,
Yes, anyone?
could you make communication with English? We are unable to understand Hindi
No,
over
I
here.
cannot. Actually, I am very sorry. लेकिन I will be conducting it in like a hybrid sense ताकि सबको समझ आए. सही? If there's any question, if there's something you cannot understand, you can just ask me, say it, and then I'll convey it to you in English. That is something I can
Yep.
do. Okay?
Yep.
Okay. So VPNs are virtual private networks. ठीक है? वो connect हो सकते हैं बाकी दूसरे network से. ठीक है? तो उसका हम ये करेंगे कि जैसे फॉर एग्जाम्पल अब यहाँ पे लिखा हुआ है ये हमारे जो है क्या बोलते हैं 5 तरीके हैं जिनसे हम अपने वर्चुअल प्राइवेट नेटवर्क को हम लाइक हमारे क्लाउड प्रोजेक्ट के अंदर जो हमारा वीपीएन है हम उसको दूसरे नेटवर्क से कनेक्ट कर सकते हैं सबसे पहले हमारा आता है आईपीसेक वीपीएन प्रोटोकॉल सो आईपीसेक इज इंटरनेट प्रोटोकॉल सिक्योरिटी ठीक है सो व्हाट इट डज इज कि इसमें हम दिस प्रोटोकॉल इन इटसेल्फ ये क्या करता है कि ये एक जैसे टनल बना देता है ठीक है for your VPN over the internet to secure your network. लेकिन it's not really that secure. Another thing that it uses is हमारा router. जैसे जो routers का function होता है कि आपको वो जो है IP addresses को वो catch कर लेता है ठीक है जितने भी IP addresses होते हैं that is another thing that it provides. लेकिन then again, it is not secure क्योंकि what it does is it exposes your internet or your virtual private network to the internet. ठीक है तो उसमें वही बात आ जाती है कि इन्वेजन एंड एक्सपोजर के जो है लाइबिलिटीज हमारी आ जाती हैं सो उसके अलावा वी हैव डायरेक्ट पेयरिंग नाउ डायरेक्ट पेयरिंग इज के गूगल के नेटवर्क में पॉइंट्स होते हैं जो गूगल का जो इंफ्रास्ट्रक्चर जो है ग्लोबली डेटा सेट्स जो उसके अराउंड द वर्ल्ड जो स्प्रेड हैं उसमें एक चीज है कॉल्ड पॉप्स पॉइंट्स ऑफ प्रेजेंस सो इन दैट ये होता है हमारे साथ कि पॉप्स में जो है वो जो एरिया होता है ना दैट इज डायरेक्टली वहां पे इफ यू प्लेस वो डायरेक्ट पेयरिंग gives you is कि you can place your router within a point of presence ठीक है like the area of the data center and get a direct connection to Google का network ठीक है गूगल का जो इंफ्रास्ट्रक्चर है जो ग्लोबल है उसके अंदर आप अपना नेटवर्क डाल सकते हो ठीक है this is something you can do another thing you can do is कि for example your business is not near to a pop ठीक है तो what you do is कि आप फिर कैरियर पेयरिंग लेते हो अच्छा वन ऑफ द थिंग्स दैट डायरेक्ट पेयरिंग गिव्स अस इज एसएलए होता है हमारा सर्विस लेवल एग्रीमेंट जो आप गूगल के साथ बनाते हो अगर आपका जो है टोपोलॉजी अच्छा अगर आपका टोपोलॉजी क्या होता है टोपोलॉजी बेसिकली ये होता है कि आपके कंपोनेंट्स एक दूसरे से इंटरैक्ट कैसे कर रहे हैं अगर आपका टोपोलॉजी गूगल के रिक्वायरमेंट से मिलता है तो फिर आपका जो है ज़्यादा अच्छा आपका एग्रीमेंट लेवल बन जाता है फिर उसके बाद हम आते हैं कैरियर पेयरिंग में इसमें ये होता है कि देर आर थर्ड पार्टीज ठीक है what you do is कि they provide you the router it's their router is in a pop ठीक है और फिर they provide you that network right जैसे ये जो इंटरनेट कनेक्शंस हमें प्रोवाइड करते हैं वैसे लेकिन इसमें देन अगेन फिर वो एसएलए की जो ऑथेंटिसिटी है वो प्रोवाइड नहीं होती क्योंकि फिर गूगल उस चीज़ में इंटरफेयर नहीं कर सकता फिर आप जानो और आपका वेंडर जाने ठीक है दूसरी चीज है डेडिकेटेड इंटरकनेक्ट इसमें आप डायरेक्ट गूगल से जाके जो है क्या बोलते हैं ले सकते हो अपना कनेक्शन इसका भी यही हो जाता है कि इसमें चूंकि अगेन आप गूगल के साथ डायरेक्टली कनेक्ट कर रहे होते हो अपनी चीज को तो फिर आपका ऑथेंटिसिटी बढ़ जाती है और पार्टनर इंटरकनेक्ट ये होता है कि उसमें आप क्या बोलते हैं, उसमें भी यही थर्ड पार्टी वाली चीज आ जाती है, लेकिन वही एसएलए वाली जो ऑथराइजेशन है उसकी इतनी ऑथेंटिसिटी नहीं रहती, वहां गूगल इंटरफेयर नहीं कर सकता ऑब्वियसली। अच्छा नेक्स्ट, oh sorry, these were the slides actually. Okay, so now what is load balancing? Load balancing, as just for example, if we focus on this diagram, what load balancing is doing is कि ये जो तीन instances हमें show हो रही हैं, it is taking the network from these three instances and it is, yeah, it is taking the load from these three instances, and इस diagram में it is giving them out to your laptop, your PC, your phones. सही है, like it says, it
Ma'am?
balances the load. Yes.
Ma'am, the load balances. You are saying that the load balances acts like dividing the part of a network or whatever service which was provided by the Google or some any cloud platforms, and it is evenly distributed without any imbalance or without any disturbance or something at imbalancement. Are you saying it's like that? Because of the major of the conversations are
Yes.
in English.
Yes, well, what it does is that basically, if for example, now you cannot predict when your application is going to be experiencing a large amount of load, or when your
Yeah.
application will not be experiencing any load, right? So, for example, if there is a load that requires a lot of storage, or a load that is requiring a lot of CPU utilization, it will automatically it could either on the peak of load, it could even multiply your instances and then distribute loads accordingly to that, or what it can do is decrease the number of your instances ताकि the load क्योंकि load इतना है नहीं तो इतने सारे instances sorry if
Many
because there is not
instances. Many
so much
instances. I
load.
can understand.
या ओके, तो अगर इतना लोड है नहीं तो फिर आप इतने सारे इंस्टेंसेस का क्या करोगे, राइट? वो आइडल पड़ी रहेंगी एंड दे गोना बिकम यूजलेस, तो वो उनको डिक्रीज भी कर सकता है। तो किसी भी किस्म की इम्बैलेंसिंग जैसे आपने बोला होती है ना, वो उसको बैलेंस कर देता है, उसको जो है डिस्ट्रीब्यूट कर देता है, ताकि आपकी एक इंस्टेंस पे बहुत ज्यादा प्रेशर ना पड़ जाए, क्योंकि इन अ लॉट ऑफ प्रेशर इट्स गोना ब्रेक। ठीक है, अच्छा, oh sorry, right, here we are. Again, so yeah, so it's like it says, it's fully distributed software defined managed service, the cloud load balancing. अब यहाँ पे Google की provided cloud load balancing की बात हो रही है, and what it does is कि these are all the types of traffic that it can help. HTTP is your web traffic, transmission communication protocol, control protocol, that and your secure sockets layer and your UDP, all of these sorts of loads it can take care of, all of these sorts of traffics it can take care of. Another thing that it does is, अच्छा, another थिंग, एक और चीज जो ये प्रोवाइड करता है वो ये है कि नंबर वन, एक तो ये आपका सिंगल जो है क्या बोलते हैं एज वेल एज क्रॉस रीजनल लोड बैलेंसिंग। अब इसका ये मतलब है कि फॉर एग्जांपल, अगर आपके एक रीजन के अंदर मल्टीपल सबनेट्स हैं और उसके अंदर आपके इंस्टेंसेस हैं, तो ये आपके रीजन के अंदर भी काम करेगा, या अगर आपकी एप्लीकेशन मोर ग्लोबल है तो ये क्रॉस रीजनल भी काम कर सकता है। ठीक है, इंक्लूडिंग ऑटोमेटिक मल्टी रीजन फेल ओवर। नाउ व्हाट डज दैट मीन? इसका मतलब ये कि फॉर एग्जांपल, अगर जैसे यूजुअली ये गुड प्रैक्टिस होती है कि आप मल्टीपल सबनेट्स में या मल्टीपल रीजन्स में अपना एप्लीकेशन की इंस्टेंसेस को लॉन्च करो, कि इन केस अगर कोई एक जगह फेल हो जाती है तो आपका दूसरा रीजन चल जाएगा। ठीक है, वो आके उसकी जगह ले लेगा। तो वो कैसे होता है? वो लोड बैलेंसिंग से ही होता है कि आपका जो क्योंकि आप अपने लोड बैलेंसिंग पे क्या करते हो, आप एक हेल्थ चेक लगाते हो, ठीक है, और फिर वो बार बार चेक करता है कि सारे इंस्टेंसेस सही चल रहे हैं या नहीं चल रहे। जैसे ही कोई इंस्टेंस फेल ओवर होगा, वो आपका लोड बैलेंस ऑटोमेटिकली स्विच कर जाएगा ऐसे। एंड नो प्री वार्निंग, जैसे वही बात आ जाती है, फॉर एग्जाम्पल अगर एकदम से मेरा लोड बढ़ गया तो आई डू नॉट हैव टू पास अ टिकट और अ टोकन अलार्मिंग माई एंटायर सिस्टम दैट यू नीड टू बी प्रिपेयर्ड कि एक बहुत बड़ा लोड आने वाला है। नहीं, लोड बैलेंसिंग खुद उस चीज को केटर कर देता है। ओके, लास्ट, these are the types of load balancing options we have, ये इन sorts of सारे traffics को cater करता है। अब now let's get okay guys, so what is happening is कि ये कॉल 15 मिनट्स में एंड हो जाएगी। what you'll have to do is कि आप इसी लिंक पे फिर से ज्वाइन करोगे, सही है? ऑलराइट, अब हम अपने लैब पर आ जाते हैं। अच्छा, wait, this is the one, right? यहाँ पे वही हमारा सारा लोड बैलेंसिंग के हमें ऑप्शंस दिए हैं. अच्छा, अब इस डायग्राम पे अगर हम थोड़ा सा फोकस करें, तो यू एज यू कैन सी ये हमारा एक लैपटॉप है और हमारा लैपटॉप इज गिविंग अ रिक्वेस्ट टू द इंटरनेट. अब वो इंटरनेट से हमारे पास आ रही है रिक्वेस्ट हमारे जीसीपी के अंदर. ये जो गूगल ये जो क्लाउड लोड बैलेंसिंग का ये लिखा हुआ है, ये सारे वो प्रोसेसेस हैं जो हमारे लोड बैलेंसिंग के अंदर होते हैं. एनी कास्ट आईपी यानी कोई भी आईपी अंदर आ रही है, और ये हमारा फॉरवर्डिंग रूल है, यानी वो ये फायरवॉल रूल होता है. ये जो है अब उसको फॉरवर्ड कर रहा है कि ये जो आईपी है, ये जैसे फॉर एग्जांपल हमारा डीडॉस अटैक नहीं है या कुछ नहीं है, तो इसको आगे कर दो. अब ये टारगेट प्रॉक्सी क्या होता है? टारगेट प्रॉक्सी आपको बेसिकली ये बोलता है कि ये इसको टारगेट्स तक पहुंचा दो. टारगेट प्रॉक्सी भी फायरवॉल रूल में ही आता है, और ये हमारे टारगेट्स कौन है इधर? हमारे इंस्टेंसेस. फिर उसके बाद यूआरएल मैप में आ जाता है, और फिर ये हमारी बैकएंड सर्विस. बैकएंड सर्विस अगेन देखिए यहाँ पे हेल्थ चेक लिखा हुआ है, ये भी फायरवॉल रूल होता है. जो हमारी बैकएंड सर्विस क्या है? हमारी ये दोनों इंस्टेंसेस हैं, ये पूरा मिला के एक बैकएंड सर्विस बनाती है. तो हेल्थ चेक होगा कि ये सब कुछ सही चल रहा है, हाँ चल रहा है. फिर उसके बाद नीचे ये इसके अपने फायरवॉल रूल्स हैं. फायरवॉल रूल्स क्या, कि किस किस्म का ट्रैफिक होना चाहिए और क्या कैसा ट्रैफिक होना चाहिए, और ये सारी चीजें. फिर उसके बाद वो हमारे इस और ये पूरी चीज अभी नीचे, ये पूरी चीज हमारी नेटवर्क है. अब एक चीज आप लोग ये नोटिस करो कि क्लाउड लोड बैलेंसिंग हमारे वीपीएन के यानी हमारे नेटवर्क के बाहर लगता है. हमारे नेटवर्क के अंदर नहीं लगता, हमारे नेटवर्क के बाहर लगता है, क्योंकि वो हमारे नेटवर्क को बाहर के नेट से, बाहर के ट्रैफिक से कनेक्ट करता है. सही
Can
है?
you explain
तो
this
अगर वो
point in
हमारे
English? I cannot understand this.
यस,
Yeah, please explain that about topic in English. Something little bit I can understand because of the language
okay,
linguistic.
okay, it's okay. It's okay. So what is happening in this diagram is कि first of all we are receiving a external request from our laptop as it is shown in the diagram, right? Through the internet. Then that request is entering within our GCP platform where our project is residing. Okay. As you can see, this is the cloud load balancing, and all of these steps are what is going inside the cloud, inside the load balancing. First of all, when we get that IP address is verified at the Anycast IP. So for in order to as a check against, let's say for an example, DDoS attacks. Okay. And what happens is that then we go through our global forwarding rule. This global forwarding rule basically says that this is a good IP address, no problems within it, so pass it forward. Then it goes to our target proxy. Target proxy is also a firewall rule. What it does is the targets here are our instances, both of these instances that you can see. So what it does is it tells the load balancer that this IP address that has come, this request that has come from this external IP address, this needs to go to these targets. These are the targets that you need to take it to, because the load balancer needs to know where to send the traffic, right? And then you have your URL map, and then you have your backend services. So these both are your both of these instances are what are making your entire backend system. And with the backend service, as you can, I think I explained this diagram already. HTTP load balancer with Cloud Armor. So, what is Cloud Armor? As you can see, what's written over here, okay, it enables you to restrict or allow access to your load balancer at the edge of the Google Cloud as close as possible to the user and to malicious traffic. As the name suggests, Cloud Armor, right? So it's basically what it does is, again, when I explained to you this, any cast
It's a
IP with
personal
global
identity to
forwarding
access
rule.
the instances.
Yes, can you repeat that?
It's a personal identity. We have a username or a specific username or specific user ID to access it. Likewise, in computing instances, we are accessing. If you are logging in with gigs for gigs or something as a Java T point, we have a specific access. Your ID. Likewise, the armor is identifying and judging your IDs. Am I right, now?
Yes,
Okay.
exactly. Because as let me just right, as it does, it says ke IP allow list and deny list, right? So what does it do? For example, if your IP address is showing some any signs of any sort of malicious activities, it will block you, so that you cannot overload the load balancer itself, right? Now moving forward, I'm sure all of you must have followed with the Start Lab video that was uploaded. Right. We can. Acha, one thing that everyone needs to take care of, like in all of your labs, all of your labs, is that when you open your virtual Google Cloud Console, you are supposed to do it in an in private window. Can everyone see both of my screens? I'm sure you all can. Right. And God. Acha. So I'm just gonna enter my password, not my personal password, not my personal ID. This is the ID that I need to enter that is provided over here. Right? This is my project ID. Sure. Now I'll be going back. If you cannot see anything, you will have to tell me by voice because I am not really on my Meet tab right now. I am on my other two tabs. So I will not be able to see any questions on the messaging block. Right. So if you go down, I have authorized my account. Right. So better what we're going to do is we're going to configure the HTTP and health check firewall rules. So it's asking me, can I go to my VPC network in order to add my VPC firewall rules? VPC network, firewall, right? What sort of firewall rule am I adding over here? I'm adding my HTTP firewall rule that will allow access to my instances of the requests that come from HTTP, that are HTTP requests. Okay. Now, if I go down, I see I already have a lot of default firewall rules. Now, when you create a VPC, when you have a default VPC, that default VPC already has a lot of firewall rules, right? But I am going to be configuring my own instances, so I will need a more specific firewall rule for that. So we have two things. We have a firewall policy that would be a set of rules that will be applied to my rule, but right now I do not need to be setting a policy, I need to be setting a rule. Acha. Default allow HTTP. फिर उसके बाद network. My network is my default network. Targets are my specified targets, and my specified targets tags would be the HTTP server. Now, why am I adding a tag? I am adding a tag such that when I will be going to my instances, I will be adding the same tag to those. Tag basically is like a heading. When you are making your instances, when you are configuring your load balancer, when you are configuring your rules, how will they know that they need to connect to each other except for adding the IPs here, right? They will know them by tags. You need to put tags on your individual resources that will tell them that this is the tag that I need to be connected to. If a service has this tag, then I need to be connected to this tag, right? They all are binded to each other by tags. The source IP, the source filter is IPv4 ranges. The sources are this. Now, source means where should be the request coming from. The reason why we're adding 000 here is because it can come from any IP, right? Because we are going to let in requests. There are HTTP requests that are from the web, right? So any IP protocols. Okay, specified protocols, we have our TCP protocol and on the port 80. That's it. We click create. Usually the configurations, they take time according to how many configurations you've done or how big of the configuration is. There are some services that require a lot of time to come up because after you are done configuring them, because of it having to create and sort the system within itself, right? Now we need to create the health check firewall rules. The health check firewall rules are basically, like I said, they're going to be checking the health of your instances, your backend servers. The health checks determine which instance of a load balancer can review new connections for HTTP load balancing, right? Like it's written over here. So still in the firewall rule page, I need to be creating my firewall rule. Name would be default allow health check, right? Network would be default. Targets are my specified targets. My target tag, again, my HTTP server is my target tag, so that this health check knows where it needs to be placed, where it needs to place itself. Now, my IPv4 ranges. Where is this supposed to come from? It's supposed to come from these two specific IPs because these are the IPs that are relevant to my instances on which this check is being placed. Right. 5.191.0.0.16. Perfect. Right. Protocols and ports, just TCP. That's it. No specific port because this is internal. Create. Okay. Again, no specific port is being defined on the TCP protocol here. Why? TCP is your transmission protocol, it's the communication protocol. No specific port because this is an internal thing. This health check is inside and it will be checking the instances which are inside the network, right? So no port. You use the port when you want your request to land on your computer. When it's coming to your computer from outside, you specify on which port do you need to receive this request from. For example, the airport. Then okay, I have configured this should be right. Good. Now we configure the instance templates and we create the instance groups. Why? What instance template does is if I need to have multiple instances, I will not go and configure each and every single instance. No, I will create an instance template, and then within using that instance template, I can create instance groups. Why instance groups? Instance groups because if I want to have different subnets, in my instance template, I will be just specifying a single subnet for temporary reasons, and then whatever CPU or storage or memory or core that instance will have, that comes in the template. And then I can copy that template and create my instance groups. And in my instance groups, then I can configure which specific subnet or region this instance needs to be placed in. So we need a template for US East 4 and one for Europe West 4. So we can go to our compute engine and our instance templates. We don't really have an instance template for by default because that is something that we need to give this to. We need to configure the instance template. It does not provide to us by default like the firewall rules. The name, okay, so the name is US East 4. Series E2 machine type E2 micro advanced options. Networking again. It's asking me to put my network tag, which is the HTTP server, so that the instance knows where it needs with what it needs to be connected to. And then I have my click default under network interfaces default in order to edit it. Network default subnet. There we go. I will be having my default US East 4 subnet because that is where it needs to be. Perfect. Just click done. Click the management tab. Acha. Now what is metadata? Metadata is basically an information that describes the type of data you have, right? So why are we adding metadata over here? We are adding metadata on this instance so that when this instance starts running, it knows what it needs to be doing. This is the entire script that it will start running the moment it is up and coming. Let's define over here and then we create. This is a template number 1. Okay, in order to go ahead, first we wait for our previous template to be created properly so that if in case any errors arise, we would know what to do and we won't be wasting time. So let's wait for this to come up. Since we had a lot of configurations, this will take a little time. There we go. Took less than expected. Let's create a new template. Uh, wait, can click on this. Create similar. We can just change the name. Change the name to Europe. Just 4. And if we go down to our advanced options, we need to add a tag. And we need to change this because this is not in Europe anymore. It's Europe West 4. Click done. It must have, we can go and check the metadata. There we go. It still has the metadata and we can create. Perfect. Our templates are up and running. And now from these templates, we are supposed to create instance groups which will contain our instances. Right. Let's wait for this to start running. Okay. Just still compute engine, click on instance groups. Now we have something called, here we go, instance groups. Create an instance group because we don't have a group by default. Name the US East for MIG. Location. Instance template, it needs to be in the US. It belongs from the, it should be created from the US East 4 template. Location, we have multiple zones because we are currently working with 2 different zones, right? So the region that we are working with, that this group needs to be created in, is the US East 4 region. The zones, it configured itself. Minimum number of resources, 1, and maximum number of instances, 2. This is for auto scaling. In so what will happen is, okay, when this will be created, it will just create one instance. But if, for example, my load peaks, it will automatically add another instance which will belong to the same instance group following the same template. So 2 maximum instances, not more than that. And then in the signals, CPU utilization, I am increasing my CPU utilization 80. When my CPU utilization on my first instance becomes more than 80 or equivalent to 80, that means my load is peaking. So multiply my instance, add another instance. This is what this is suggesting. And I can just click done over here. Initialization period 45 seconds. This says 60 seconds, which is a minute, and that is a very long amount of time. So I'm just saying, in within 45 seconds, get another instance up and running. And the autoscale performs automatic scaling based on measuring load. You can read that here, and then we created one instance group. This is taking long because of the set of configurations that we did. Because we even changed some of the default configurations. We wait. Perfect. No, it's still not. It's still, the status is not complete. It's still creating. Can wait a little longer. If it's taking too long, we can also refresh to see whether. There we go. Perfect. It's running now. Now we can create another instance group. Naming conventions are very important so that you do not get confused which resource is supposed to be doing what or what resource were you supposed to use. Therefore, naming conventions are very important. This Europe West 4 MIG instance group is supposed to use the Europe West 4 template. So that's the instance template that it's supposed to use. Multiple zones. Region is the Europe West 4, Netherlands. Hmm. Again, auto scaling 1, maximum number 2. Then we go down. CPU utilization on 80, add another instance. Done. Oh, sorry. And what is supposed. Oh, initialization period 45 seconds. Right, right. And then I can click create. Now let's wait for this to come up. Again, it will take a little long, but I can also refresh it. Although it will still. There we go. It's resizing 0 instances, scaling to 1. It's still running. The configurations are still running. This instance group is ready. Can refresh. One thing that we need to check is here in the US East 2 group, we have one instance. Why? Because we currently our CPU load is, well, it's not really using the instance, right? This will become 2 automatically when we will have a peak in our load. Similarly, even in this group, the instance size, the instance number is 1 because we are not requiring another instance. So why abuse or render an instance useless? Okay, now we will be verifying our backends. We can go to our compute engine and the backends that we just created. We can go and check those. Here we are. We have 2 instances, our Europe West 4 instance and our and our US East 2 instance. These instances are part of the managed instance groups. They come from the instance groups. If I click on the external IPs of these, I had a script running in this, right? So this is a script that is running within my instance. It's giving me the client IP. This is my IP. The IP of the instance. This is the host name of this instance. The location of this instance. Where is this instance running? Everything. I can go to the US instance as well, and it will be giving me its external IP. There we go. My IP, the host name, and its location. There we go. Which of the fields identify the region of the backend? The region service location does that. Submit. So these fields identify the region of. Let's skip this. Configure the HTTP load balance. Right. Right. Over back here. Right. Navigation menu, network services, and load balancing. We'll have to go a little down. Network services, load balancing. And now we need to create the load balancer that will be distributing the loads across these instances, right? So we create the load balancer because again we are not provided a load balancer. Now what type of load balancer do we need? We actually need an application load balancer. So we start the configuration from this one, internet facing, from internet to my VMs or serverless. See, not we will not be choosing the only between my VMs because this is not an internal load balancer. This is an internet facing load balancer. And continue. The name is HTTP Okay, so we're going to click on the front end configuration. These are the front end configurations. IP version is IPv6. IP address is supposed to auto allocate and port is 80. Click done. Then I go down. And there we go. Configure the backend. I can go and configure my backends. Create a backend service. Okay, create a backend service. The name would be HTTP backend. Instance group would be, it's supposed to belong to my, it's for my US East 4. Okay, and something that you need to notice is that I have accidentally placed the wrong name in my instance group. I can go and actually fix that. I can just go and fix that. Cancel. VM machines, instances. Actually, might need to go to my instance groups for that because that problem will be in my group. I can just go to my group. Right, I can go to my group. Yeah, see? Edit my group. Change the name. East 4 template. Yes. Huh. Okay, so I cannot change the name. It's fine. Because if it is reading the existence of my instance, then the naming convention should not be a problem. Going back to my load balancer. Wait. Network services. Yeah, we'll be creating a load balancer, an HTTP load balancer, internet facing. Continue. I am going to be naming it my HTTP LB. My front end configuration suggests HTTP IPv6. It's supposed to be auto allocating. 80. Done. Done. Backend. Then backend. I need to create a backend service. Name would be HTTP backend. My instance group would be my yeah, my backend type is my instance group, and the instance group would be the US East 4. My port numbers would be land on port 80. Balancing mode is rate, the rate of usage. I have my maximum rate per second, request per second. I have 50. Capacity is 100. There we go. Just click done. And then I can add a backend because we actually have two backends, right? That is why we'll be adding a backend. A Europe for same port rate. No, this one is for utilization. The maximum requests per second are 80 and the capacity is again 100, right? So this suggests that my US East 2 backend is supposed to be taking care of the rate, right? And my Europe West 4 is supposed to be taking care of my CPU utilization. They aren't saved, but it's fine. Attempts to keep the instance. The Europe West 4 is keeping it below 80% CPU utilization, whereas the load balancer attempts to keep each instance of US East 4 or below 50 requests per second. There we go. Okay, we are done with that. Now we can create a health check. Done with the. I'm very sorry. It's just. It's on the side pane, therefore it's kind of confusing. For health. Ah, sorry. I was missing this part here. I will be creating a health check for my instances, right? Its name would be HTTP health check. Protocol TCP on port 80. There we go. What does it do? It determines which instance receives new connections, right? Waits up to 5 seconds for a response and treats two successful or two failed attempts as healthy or unhealthy, respectively. Save. I will be enable logging. Why am I enabling logging? So that I know what is happening to what instance at what time or how much is an instance is being utilized. In order to keep tracks on what is happening to my instances, how are they being required, I will be enabling my logging. Sample rate 1, create backend service. Okay, there you go. And now I can create. This will take a while. It will take a while because of the amount of configurations we did. We created two backends and we also created a health check for them. So therefore, in order to configure all of the system, all of the arrangements we have done, it will have to take some time. There you go. Can refresh again. It's asking me to go and copy my IPv4 and IPv6 addresses. I can do that. I'm gonna do my load balancer. Hmm. Right. I go back. Hmm. This is the only address it's providing me with, so I can just copy this address and save it on a notepad. In case I will be requiring store it somewhere. There you go. Alright. Hmm. Okay, so apparently I have made some mistake in the forwarding rule. We can go and in the forward and create a form with required configuration. Huh. That is not right because I have followed all the steps. Ah, I haven't really added the front end IP, have I? Hmm. Maybe we're going to edit this. I've missed my front end IP in this part. This part I have missed. That's why it is asking me to go and configure my front end rules, no forwarding rules. So my front end IP uses the HTTP protocol, the IPv6 version, auto allocate. There you go. Done. That's it. I can update. I'm done updating. This is supposed to be. This check is supposed to be successful. Just wait for this to update. Okay, perfect. Done. Hmm. If I go back, you can see that I have two addresses. One is for my IPv4 and the other is for my IPv6, right? I need to copy this one. Perfect. Oh, sorry. There you go. Now if I ask it to check my progress, I still have not created the forwarding rules with required configurations. Ah, yep. Need to go back. So in my front end configuration, what I did was I accidentally mixed. Wait, let me show you what I did. So here, as you can see, if I go to my front end configuration, right, my front end configuration, I have two of these. First of all, I'm not supposed to. Second of all, this is supposed to be IPv4 and it is supposed to be ephemeral, which it is IPv4. Mm-hmm. Hmm. You can just redo this entire thing. IPv4 ephemeral port 80. Done. Add. Go down. HTTP IPv6. Auto allocate port 80. Done. Update. This will take a while again. I am so sorry for the delay. Just a little longer. There we go. Now, our addresses, as you can see over here on our front end, right now we have two different addresses. This is the IPv4 address because this is the format of an IPv4 address. If I do this, Control V, and this is the format of an IPv6 address. Control C, can come down here. Control V. There we go. Perfect. Now it is actually not supposed to cause a problem. Perfect. The HTTP load balancer should forward traffic to the region that is closest to you. Access the HTTP load balancer to test. Open a new tab. Okay. Now it wants me to test whether this load balancer is working or not. So how will I be doing that? HTTP and the IPv4 address. It needs me to add the IPv4 address. Control C. Control V. 404 or 502 error. Keep trying until the page gives one of the backends. You're gonna wait for that. Okay. Now, if this is saying it might take up to 5 minutes to access the HTTP load balancer, we don't really have that kind of time, right? So let's move forward. We can come back to this. I can just go and reload this page. So we'll come back to this. Now, stress test the HTTP load balancer. Acha. What this is going to be doing is it's going to ask us to use Sage. Sage is basically a package that is used to simulate any of the extra requests or any sort of load in order to test whether our instances, our load balancer is resilient or not. You can just go to my compute engine, VM instances. I will be creating a Sage VM. What's going on? Why is it not listening to me? Why is my keyboard causing a problem? Nope. Okay. It's fine. Why is this not working? Okay, yes. Hang on. I'm just. I'm placing this in a separate region, in the Oregon region, in a separate zone. This shows that this is a different instance that will be sending the request to my load balancers. That is what this will be doing. And this meeting also ends in 15 minutes. Kindly rejoin by the link that Hira will be providing in the group. There we go. You just click create. Create. We wait for this instance to be created. Shouldn't take a long while. Just refresh it. There we go. Achha, now it wants me to go on the SSH that belongs to the Sage VM. And it wants me to install Sage on this instance because we will be forwarding traffic from this instance to the load balancer, right? So for that, we'll be running some commands. Right. सबसे पहला command would be sudo apt get y install Sage. Now this is a Linux command. We can go through this command, right? Sudo is basically a keyword that is referring to me, the account owner, the authority. It's referring to my authority over this account. Apt dash get. This this command basically means that it refers to anything, any package that I need to install, that I need to manage. This is what it's referring to. Minus y is when the console asks us if yes, do we want to perform this action or not. So I'm pre-adding the minus y in order to tell my console to yes, do perform the do perform the task, and do not ask me. And then I'm adding the install siege. Now since apt-get, it kind of installs, it updates, and does all these three things. So I am telling it that in all of those I need to install siege. It's going to be installing all of this. Okay, it's done. And then we store the IPv4 and address in a specific variable of ours, that so that we don't really have to add the IPv4 address in every single command that we use. And just Control C, copy it over here, Control V, enter, done. Just Sage C, Control V. Now what does Siege C mean? Siege minus C means stimulate, create the I'm sorry, I'm forgetting the word. Create the basically just create the custom 150 and in 120 seconds, and this is the IP that I'm providing it. Send the load to this, right? This is what it's doing. I can just click back and it's asking me to go back to my console. My console. Where's my console? This is my console. It wants me to click network services. It's asking me to go and check my load balancers. Load balancing. Backends. It's HTTP backend. HTTPLB. Monitoring. There we go. As you can see, it is using the forwarding rule 3. The URL, this is the load balancer section. The URL rule. So what is the space? This is the URL rule. The total response traffic, right? And going to the backend service. Perfect. Here we are. Now it wants me to return to my SSH. Control C will stop the entire. Okay, perfect. Yeah, this is what I got. The number of transactions, the availability was 100, the elapsed time, the time, total time, data transferred. There we go, perfect. Right? Now, deny list. Now, what it wants me to do, it needs me to create Cloud Armor in front of my load balancer such that I deny any request that is coming from my Sage VM. Right? So, I'm going to go to my console and navigation menu, compute VM instances. Navigation menu, compute engine. Sorry. VM instances. Here we are. Note the external IP. I will be noting the external IP of my Sage VM. Control C, adding it. Control E. Might need it. Cha. Navigation menu, network security, and cloud armor policies. Cloud armor policies. Create a policy. Analyst. Sage. Default. Rule action is supposed to be allow. Yeah, it's supposed to be allow. Click next step. Then I add a rule, and in the rule condition match. This is the siege IP that I need to control C, control V. There you go. Action is deny this IP, give the response code 403 forbidden, and priority is 1000. Done. There you go. Next step, add target, load balancer backend service, HTTP backend, cancel. What? Place. There you go. Create policy. We have a default security policy. There we go. We can go back to our we can check that we have created this deny list. There we go. So now we can go back to our SSH terminal, and this time it is not supposed to be able to do that. Shall we? There you go. It does. It passes this, and now I can just open a new tab. Open a new tab. HTTP IPv4 truly Control C. Control V. Now it's working when it's not supposed to be working. PV4 of the load balancer. Oh right, this is the wrong IP address. No, it's the right IP address. You can access HTTP from your browser because of the default rule to allow traffic. However, you cannot access it from the Sage VM because of the deny rule. Right? So basically, it's saying okay, this is supposed to happen. This means our load balancer is running. If I run this command over here, suppose the security policy can go back to my policies. Go to my policies. Then I list Sage. I'm going to check my logs in this. Click on logs. Okay, logs. The call ends in 2 minutes. These are my logs. Next. Close. Key. On the login page, make sure to clear all the text in the query preview. Right. The query preview. Remove all the text. Application load balancer. Okay. Resource 2. Application load balancer. HTTP apply. There we have it. Now these are all of the querying results that have come from, as you can see. There we go. In all of these times, these are the warnings. This was the info. This is the entire log behind my forwarding rule, right? My policy. Okay. Click run query. I need to click on run query. Run query. Get this output. This shows me how and what was happening within my backend service. Span using payload, and there we go. That's it. That's all we had to do. Thank you so much, everyone, for coming to this workshop, and that's about it for the third workshop. Thank you so much for entering. Allah Hafiz.